Okay, I'm going to do a video of an example of finding finite sums using the summation formulas and taking the limit as n approaches infinity. This can sometimes be a complicated process, so I think a video here, a demonstration of it that you can watch over and over and over again, might be helpful. So the example we're going to do here today is going to be f of x equals 3x to the fourth minus 10x minus 4. And we're going to go from 0 to 3. Now I wanted to show this visually as well. So here's the graph of it. This is 0, this is 3. And it does go through 2, by the way. If you put 2 in, you get 0. That is the x-intercept. And if you notice, some of this one is below the x-axis, which means that when you add up the areas of these rectangles, they're going to be negative because they go down into the negative y's. So this is a negative area here. This is a positive area here. So of course, the question is there more positive area than negative area? And if it's so, then the actual area will of course be positive. Or is there more negative area than positive area? Then the answer will be negative. And of course, the area could be 0. They could cancel each other out exactly. So we'll see. Okay, so what we have is we have 3x to the fourth minus 10x minus 4 from 0 to 3. So the first thing we have to do is find the width. The width is b, the right endpoint, minus a, the left endpoint, all over n. Or in this case, 3 minus 0 over n, which is 3 over n. Okay, that's the width. b minus a over n is always what we use to find the width. Now the next thing we need to do is we need to find all of our little x sub intervals, or x0, x1, x2, x3, x4, xk, the general form for all of our subintervals. Well, all that is just the width times the whatever subinterval you're on. If you're on x3, you're going to be on 3 widths because we're starting at 0. If you're on x7, that's 7 widths because you're starting at 0. Okay, so anyway, that's delta x, not delta k. So this is equal to delta x, which is 3 over n, times k, which is 3k over n. Okay, and that's our xk. The next thing we're going to do is find our height. Our height is the evaluation of the original function with x being 3k over n. So we put 3k over n in for x. By the way, that was 3x to the third, not 3x to the fourth. 3x to the third minus 10x minus 4. So we're going to put 3k over n in for x. So h is equal to 3 times 3k over n to the third. That's 3x to the third, or 3 times 3k over n to the third, minus 10 times 3k over n, that's minus 10x, minus 4. Now let's simplify this out. So this is 3 times 27k to the third over n to the third, minus 30k over n minus 4, which is equal to 3 times 27 is 81k to the third over n to the third, minus 30k over n minus 4. Scroll down a little bit here. Okay. All right, so that's our height. So now we know that area equals width times height. So in this case, it's our width, which is 3 over n, times our height, which is this, 81k to the third over n to the third, minus 30k over n minus 4. So let's simplify this out. This equals 243k to the third over n to the fourth minus 3 times 30 is 90, minus 90k over n squared minus 3 over n times 4 is 12 over n. That's our area. Now what we're going to do is we're going to take the sum of all these areas. How many of them? Well, we're going to do n of them, because we're going to do an infinite number of rectangles. So this is sum of, just scroll back down and look at this, 243 over k to the third, 243k to the third over n to the fourth minus 90k over n squared minus 12n, so this whole thing. So this is the sum of 243k to the third over n to the fourth minus 90k to the second, 90k, not k n to the second, right? Yeah, 90k, not 90k n to the second. So I'll erase that off. See, we all make mistakes. Pen. 90k over n to the second minus 12 over n. Now, we're going to use our summation rule. That, of course, sum or difference, the summation of the sum or differences is the sum or differences of the summation. So we're going to put a sum for all of these. 243 k to the third over n to the fourth minus sum k equals 1 to n of 90k over n squared minus sum k equals 1 to n of 12 over n. Okay, now what we're going to do is we're going to pull out all of our constants, except for the 12. We'll leave that here, so then we're at least taking the sum of something other than 1. Okay, so we'll leave the 12, but all of the other constants, and that includes the n's, okay, will be pulled out front. Only k is our variable. So this equals, we're going to pull the 243 over n to the fourth on the outside of k equals 1 to n of k to the third. And then we're going to put the 90 over n squared times the sum of k equals 1 to n of k minus 1 over n times the sum of k equals 1 to n of 12. Now we're going to use our summation rules. Okay, what are summation rules for this one, and this one? Okay, so we have 243 over n to the fourth, and if you look in your notes, and remember you don't have to memorize these, what is the sum of k equals 1 to n of k to the third? Well, that is n times n plus 1 over 2 quantity squared minus 90 over n squared times, what's the sum of 1 to n of just k? That is the square root of this. That's n times n plus 1 over 2 minus 1 over n times, what is the sum from 1 to n of just 12? Well, that's 12n. Okay, so now what we're going to do is we're going to simplify. We're going to do some canceling. Any canceling that we can do, we should do. Okay, so watch carefully here, because this squared kind of confuses some. Not confuses, but it can trick up some people. We have 243. Now notice there's an n squared here. We'll put that over there. Now again, 2 squared is 4. So we have to make sure we have 4 here, n to the fourth. And then all we have left is n plus 1 squared on the inside. Okay, because the n squared went out, the 2 squared went out. Minus, here we have a 90n over 2n squared. So all that's left is the n plus 1. Minus 12n over n for the last one. This equals 243 over 4 does not reduce. That's 243 over 4. Notice that we can cancel 2 of those. So we have n squared on the bottom times, FOIL this out, n squared plus 2n plus 1 minus 90 divided by 2 is 45. Notice 1n cancels, so we still have over n there times n plus 1 minus, and then these two cancel, 12. Okay, now the next thing we're going to do is an unusual step. We took all the n's out. Now we're going to put the n's back in. So what we're going to have here now is 243 over 4 times n squared plus 2n plus 1 over n squared. We're putting the n's back inside. Minus, and we're doing this so we can do the limit. 45 times n plus 1 over n minus 12. Okay, now I can scroll a little bit more here. Okay, now we're going to take the limit. We're going to take this limit of the whole thing. We're going to take the limit as n approaches infinity of this whole thing. 243 over 4 times n squared plus 2n plus 1 over n squared minus 45 times n plus 1 over n minus 12. What what does this equal? Well, this is a constant multiple, so that gets copied down. Now, do you remember what we do here? Is since we're approaching infinity, we use our top heavy, bottom heavy rule, since these are just polynomials. So the degree of the top is 2, the degree of the bottom is 2, so it's the ratio of leading coefficients, which happens to be 1 over 1, which is 1. Oops, that's minus 45. Let me get rid of that guy right there. Okay, 45 times, same thing here. Degree of the top is 1, degree of the bottom is 1, so it's 1 over 1, which is 1 minus 12. So this is 243 over 4 minus 45 minus 12, which equals 3.75. And there it is. So it is slightly above 0, just slightly, 3 3/4, which means there is a little bit more area above the x-axis than there is below the x-axis, but not by much. Okay, some comments I want to make here is, first of all, let me get the highlighter here. Make sure you do all of these notations with the sums. People get lazy here and they leave the k equals 1 to n off, k equals 1 to n, k equals 1 to n. You've got to make sure you put that in there. If you don't, I'll take points off of that. And if you're thinking that that's kind of strict, well, it doesn't make sense if it's just a sum sign without k equals 1 to n. You've got to have that there. The other thing I want to talk about is the square here, and how people will just put the n out front and then they'll cancel and make n to the third. They forget to take n and square it. And same with 2, they'll put 2 out and they won't take 2 squared to be 4 out. So watch for that with the k cube problems. Okay, not as much of an issue with k. And of course k squared, which is not in this problem, is just a little bit of foiling. And that one's not too bad either. But the k cubes, the square really kind of messes people up there. Again, don't forget also that xk is always delta x times k. Always. In this case, it was 3k over n. It's generally going to be this number times k over n. Okay, so that's it. I hope this helps. Thank you.